So this is the infamous potato problem back in 2017, and this is a no calculator section, so you cannot use calculator for all of this. So at time t equal to 0, a boiled potato is taken from a pot on the stove and left to cool in the kitchen. The internal temperature of the potato is 91 degrees Celsius at time 0. And the internal temperature of the potato is greater than 20 degrees Celsius for all time t greater than 0. The internal temperature of the potato at time t minutes can be modeled by the function h that satisfies this differential equation, where h of t is measured in degrees Celsius, and we're also given that h of 0 is equal to 91. So part A asks us write an equation of a tangent line. Whenever you see those words, write equation of a line. Start with y minus y sub 1 is equal to m x minus x sub 1. So now how do we figure out which one is x, which one is y? So this dh over dt kind of tells you that the variable is t and h is the function of time. So I'm going to put a note to myself that y is h and x is t. So we're writing an equation of a tangent line at t equal to 0, so we can use this initial condition they gave us. When t is 0, y or h is 91. So we just need to find the rate at which the temperature is changing at time t equal to 0. And we can use this differential equation to find the derivative or the slope. So dh over dt at time equal to 0 is equal to negative 1/4. H is 91 minus 27. So 91 minus 27 is 64 divided by 4. Then our slope of the tangent line is negative 16. So what we have right now is h minus 91 is equal to negative 16, t minus 0. So this is our tangent line right over here. And then it asks us to use this equation to approximate the internal temperature of the potato at time t equal to 3. So we're going to plug in 3 for t right here and solve for h. And we're going to add 91 on both sides, so h is equal to negative 16 times 3 plus 91. And you can actually leave your answer like that. You do not have to simplify your answers. So for part B, it asks us to find d squared h over dt squared, which means the second derivative, to determine whether your answer in part A is an underestimation or an overestimation of the internal temperature of the potato at time t equal to 3. So we're going to take this dh over dt and take the derivative to find the second derivative. So d squared h over dt is equal to negative 1/4. And notice that t is actually the variable, not h. H is a function of time, so when we take the derivative of h, we need chain rule. So that's dh over dt. And we know from the problem that dh over dt is actually this expression right over here, so we're going to plug it in. So when we simplify it a little bit, negative negative becomes positive 1/16 h minus 27. And in the problem, it gave us a clue that we need to use the second derivative to determine under or overestimation, which means we have to figure out the concavity. Now it tells us from the beginning that the temperature of the potato is greater than 27 for all time. So which means h is bigger than 27, minus 27 is always positive, times another positive number. So the second derivative is always positive at all time t, which means h of t is concave up. So the graph would look something like this, and your tangent line is always below the curve, which makes our estimation using the tangent line underestimation. So for part C, it asks us for t less than 10, an alternate model for the internal temperature of the potato at time t minutes is the function g that satisfies this differential equation. And g is measured in Celsius. G of 0 is equal to 91. And we want to find the expression of g of t, and we want to use the model that we found to find the internal temperature of the potato at time t equal to 3. So since we're looking for g of t and we're given the differential equation right over here, we need to solve this. Okay, so separate all the g's on one side, t to the other side. So we have dg over dt is equal to negative g minus 27 raised to 2/3. We're going to multiply dt on both sides and divide it by g minus 27 raised to 2/3 on both sides. And I'm just going to leave this negative right over here because it makes life so much easier. So the dt will cancel out, this will cancel out, so now we're left with dg over the quantity g minus 27 to the 2/3 is equal to negative 1 dt. Now we're going to take the antiderivative on both sides, and I notice that we have an inner function right over here, so we will need to use u sub. Okay. So u would equal to g minus 27, and that gives us du is equal to dg. So dg becomes du, g minus 27 becomes u. So now we have u raised to negative 2/3 du. And we're just gonna finish up this left side before moving on to the right side. So using power rule, we can add 1 to the exponent divided by the new exponent. So we have u raised to 1/3 divided by 1/3 or multiplied by 3, and our u is g minus 27. Okay. And now on the right side, negative 1 dt, the antiderivative with respect to t is negative t plus c. All right, so now we're going to use the initial condition that g of 0 is equal to 91. So we're going to plug in 91 for g and 0 for t. So c would equal to 3 times 64 to the 1/3. And 1/3 exponent means cube root. So cube root of 64 is 4. So c is equal to 12. And we're going to take that and plug it into c. So we have 3 g minus 27 to the 1/3 equal to negative t plus 12. And it asks us to find g of t, which means that we have to solve for g. We want g alone on one side, divided by 3 on both sides. Plus 4. And then we're going to cube both sides. So G minus 27 is equal to the quantity negative 1/3 T equal to negative 1/3 T plus 4 raised to the third power plus 27. So now going back to the problem, it asks us to find what is the internal temperature of the potato at time 3. So we're going to plug in 3 for T. So we have negative 1/3 times 3 plus 4 cubed plus 27. And again, it's perfectly okay to leave your answer unsimplified like this. Yeah. But if you do want to simplify, G of 3 is equal to 54. So this is how the College Board graded the test. Okay. So a set of question is always out of 9 points. And then for part A, it's 3 points total. When you get that slope, you have a point. You have the correct tangent line is another point, and your approximation is another point. And again, I just want to remind you, unsimplified answer are okay. You will get full credit for unsimplified answers. Now part B, it's just 1 point. So you need to be able to find the second derivative and tell that it's a concave up graph and that your answer is underestimation. So that whole thing right there is just 1 point. Now a big chunk of point is in part C. It's at 5 points total. And you notice that the first point, as long as you were able to separate the variable, you get a point. So right over here, that's already 1 point. You have taken the antiderivative correctly using U substitution, that's 1 point. Using the initial condition to solve for C, that's another point. Now look at the fourth one. As long as you have equation involving G of and T, you'll get the point. So that's this one right over there. So somewhere on your paper, as long as you have this, so that you remember to plug in the 12, the C, you have the fourth point right there. And when you solve for G and your internal temperature at time T, when you have those two, you'll get that last point right there. And note right over here, if you forgot the plus C, the maximum that you will get is 2 out of that 5 points. If you weren't able to separate the variables correctly, you get 0 out of 5. And we are done.